Ask the smartest AI in the world how many R's are in the word strawberry. There's a real chance it tells you two. The answer is 3. This is a tool that can write working code, pass a law exam, and explain quantum physics, and it just lost to a 5-year-old. Once you see why, it tells you something deep about what these things actually are. And this is not some rare glitch. Counting letters, spelling a word backwards, finding which words rhyme, the simple character-level stuff a kid does without thinking, these models get it wrong constantly. The reason behind it is honestly one of the most useful things you can understand about AI, so let me walk you through it. Here is the first surprise. When you type strawberry, the model does not read letters. You see 10 letters in a row, S, T, R, a W, B, E, R, R. Why it does not see that at all? Before your text ever reaches the model, it gets chopped into pieces, and those pieces are usually not single letters. They are chunks. What the model actually sees is something more like 2 lumps. Straw and berry. Sometimes the whole word strawberry as one single lump if that word showed up often enough while it was learning. Either way, the individual letters inside those lumps are basically sealed off from it. It never looks at them one at a time. It was handed a chunk and told, treat this as one unit, and it does. Why would anyone build it like that? Because it is efficient. There are only so many common chunks in a language, far fewer than every possible string of letters, and working in chunks lets the model chew through enormous amounts of text quickly. For almost everything you use these tools for, writing, summarizing, answering a question, chunks are completely fine. You do not need to spell out strawberry to use the word correctly in a sentence. Neither does the model. We call these chunks tokens, and they are the real atoms of everything the model does. It does not think in words. It absolutely does not think in letters. It thinks in tokens. Hold on to that, because it explains almost every strange thing these tools do. To get a feel for it, here is roughly how the chopping goes. Really common words, the and is, each get their own single token because they turn up constantly. A normal word like strawberry might be 1 token, or it might split into straw and berry. A rare or strange word, a long medical term, a random username, something you just made up, gets shattered into a handful of little pieces, sometimes down to 2 or 3 letters each. Even the space in front of a word usually rides along as part of the token. So the model is reading a stream of these uneven puzzle pieces, not a neat row of letters. It learned what each piece tends to mean and what tends to come after it. That is the whole game, and it works astonishingly well, right up until the moment the exact letters are the point. So now you can see exactly why the counting falls apart. You ask, how many R's are in strawberry? To answer that honestly, you would have to crack the word open into individual letters and tally them up. But the model does not have the letters in front of it. It has a couple of tokens and a fuzzy, learned sense of what they are made of. Asking it to count the R's is a bit like handing someone 2 flashcards instead of a written word and asking how many times a certain letter appears. They would be guessing. And guessing is exactly what happens. It does not stop and count, because counting is not a thing it can actually do. Instead, it just predicts an answer, the same way it predicts everything else. It has seen plenty of text about letters and counts, so it produces a number that looks plausible for a question shaped like this. 2 feels like a reasonable answer for the R's in strawberry, so it says 2, with full confidence, having never once checked. Now here is the part people get wrong in the other direction. This does not mean the model is dumb. It means it is a different kind of thing than you are picturing. You imagine something that reads the way you do, letter by letter, word by word, that could count if it just slowed down and paid attention. That picture is wrong. It is a pattern machine working on chunks, and it is breathtaking at the things chunks are good for and oddly helpless at the few things that need the letters underneath. Both of those come from the exact same design. You cannot keep one and remove the other. You can catch this blind spot all over the place once you know it is there. Ask it to reverse a word, and it often scrambles the middle. Ask which words truly rhyme, and it leans on spelling patterns instead of sound. Ask it to write a sentence where every word starts with the same letter, and it gets close but slips, because it is nudging chunks toward a target it cannot fully see. None of these are the model being lazy. They are all the same thing. The letters are sitting behind frosted glass, and it is reading the blur. And this is not just a party trick to embarrass chatbots. It shows up in real work. Ask a model to count the words in a paragraph, or to trim a caption to exactly 40 characters, or to find every line in your code that mentions one specific variable, and it will often be a little bit off, confidently. Not because the task is hard, but because it is a character-level task wearing a language costume. The model does what it always does, it predicts a plausible answer, when the job actually needed exact arithmetic on letters it cannot really see. Learning to spot that one distinction saves you from a whole quiet category of mistakes. So how do you work around this, on the rare day you actually need character-level precision? A few easy moves. First, make the letters visible to it. If you ask it to spell the word out first, STRAWBERRY one letter at a time, and then count, it does far better, because now each letter is sitting in the text as its own little token. You did the cracking open for it. Second, for anything where the exact characters really matter, a precise edit, a count, a search and replace, reach for a real tool, or at the very least check the answer yourself. And third, just remember the blind spot is there. The moment a task is really about letters rather than meaning, that is the moment to stop trusting the confident reply. The strawberry thing looks like a silly little bug. It is not. It is a clean window into what these models actually are, not tiny readers sounding out words the way we did in school. Pattern machines shuffling chunks around with no eyes on the letters inside. Once that clicks, the failures stop being surprising, and you know exactly when to trust the answer and when to check it yourself. And that is the whole point of this channel, one clear idea at a time.